All right, it will be a demo without slides and only interactivity because we couldn't set up a laptop. Fine. So Panda, Pandalang, what is this thing? It is a programming language, and it's inspired by that. I like programming, but we've been spending a lot of time programming in the same way as we've done the last, I don't know, very long time. And we haven't changed a lot. And that is a little bit concerning. We haven't changed our efficiency in programming since maybe the beginning of time, which may be 57. We're still writing the same amount of code to do things which are very, very simple. And actually, most code, if you try to give it and explain it to your grandmother, is going to be quite impossible. Because how are you going to explain the curly braces, the semicolons, and all these kind of things? It is quite a lot of stuff to explain for even a small program, right? So I say like this: if I talk to another programmer, I can tell you like, oh, can you write a program which will take the numbers from 1 to 10 and square this number and keep all the squares less than 15. This is relatively simple and is well understood. And I met this super JavaScript programmer, and he said, oh, it'll be fast. And he loads up his editor, he starts typing, and he found it too slow to actually write the for loop, so he just wrote the list 1, 2, 3 till 10, and it was like doing something on this and then squaring them and extracting them. But it's like he had a lot of choices to do when he was doing this. And it took him some time. It took actually 2 minutes to get a program that's actually compiled, and he had to run it from Node.js from a command line. And this is the level of our art of programming in some way, right? Like I tell you, can we do a program which does this? You can't just pull up your tablet and pick away and be ready in a few seconds. It actually takes much more. And if anyone here has ever tried to program on a tablet, okay, how did you like it? Everyone enjoyed it very much. Thank you. So I did not. You had to get a Bluetooth keyboard, and if you don't have Emacs or VI or whatever your preference editor is, it's pretty difficult because you're essentially using it as a terminal in most cases. And there's a great IDEs which works on your tablet, and they try to do things, but it's toys compared to what we want to do as programmers. These are usually not very advanced languages and so on. So my approach is that I want to be able to program on the tablet. And how do we get there? Because programming is quite complex. We have for loops, we have ifs, and the syntax of these. Have you ever tried to explain the syntax of a for loop in C or JavaScript for somebody? This is quite a lot of work to understand the parts of it, and it's quite complex to actually get there. So thinking about these things, if we didn't have a for loop, if we didn't have if statement, if we didn't have any nulls, then those things might, if we had an easy way to do that, then we should do that, right? Furthermore, functional programming is great. The features of it is great because you say what you want and it computes this. But you look at a functional program as a non-functional programmer, and there's map, and there's reduce, and there's combinators, and there's things you cannot even pronounce. So you can't call up your friend and say, what does this 3 characters mean, which I can't pronounce? And this is where the functional programming has gone. There's still Lisp, which have not so many symbols in terms of funny characters. It's more word-based, and we saw a great example of a nice language earlier today, where Tulip, where it's word-based, it's simple, it has processes like Erlang and so on. So this is kind of where the future goes. So Panda is again, a language with a very simple syntax. You don't need the comma because the comma is not has no special meaning. You could write this, but Panda is actually meant to be used more like you start with data. So similarly to Tulip, you start with a value, you have a value, you see the value, you can then use this value and you say +4, and then you just continue using these values. You can say times 2 here. So we're chaining it, right? This is simple object-oriented syntax, but it's equivalent to a function name, a parenthesis, right? Just we notice that in this case, we don't need to group expressions as much. It's a lucky coincidence maybe, but I like how in many languages, we instead of having parentheses and commas, we just have spaces. But then comes the parameter, which is a complex value, and then you need to put the parentheses around it there. So you saved it in one place, but not the other place, and it became inconsistent. Why is there a parenthesis around that expression? If I put a parenthesis around the other expression too, it actually looks like Lisp in Haskell. But that's not needed. But it's also inconsistent, right? So that's an interesting aspect of it. So is this simple? Well, for math, this is probably very tedious. Where is the power in such this language? Well, the power here is that everything is a value, there's single values, and there's no multiple values. So can you read in the back, actually? Can you read the small? Okay, I probably can plus it a little bit. All right, a little bit better, great. So what does this do? Can somebody pronounce it? 1 to 10, right. So what does it do? It gives you the value 1, 2, 3, 4, 5, 6, 7, 10. So let's see. Yes, it did. All right. So it returns an array of values. No. Because now you can say +100. So what does this do? Right. So it just applies the operator on a single value. It's not like somebody was telling me when I showed it in Noisebridge in San Francisco, saying like, oh, that's cool, but I can do this in Haskell. You cheated because you created this plus operator, which actually includes the map, and it takes a list. And you created all these operators to make your examples nice. I was like, no, that's not how it works, actually. Because 1 to 10 is a function. It returns the value 1. And then that value is being processed. It's passed to the next function, which is +100. And then the value 2 is generated. And then it's passed to 100. So this is a stream of values. So every function in Panda have a possibility of returning one value or more values. So in this case, the 1.10 is actually a function called iota, which you can recognize from other languages, which is x-range in another language. So it's a generator. So a generator generates 0, 1, 2, or more values. So how does this work? We just eliminated the loop. Is it unreadable? Is it understandable? It's kind of somewhat okay. We typed very little, we got very much for it. What if we want to only get the odd values? What should we be doing? What's the best way to get the odd values? Right, so we say odd. So that gives us the odd values. All right. Okay. That's fun. How about we take these values, we square them, so we know that we've got the square. We then take the values less than 15, and then we get the values less than 15. This is not working on a list, it's working on a stream of data, right? Remember this, because even if I put a large number here, the first values comes very fast. It's continuing working in the background, and actually this machine is so fast so you can't see it happening. But you see it blinking green. So when it's green, it's working. And when it's gray, it's terminated. Okay? So this is a stream-based, it's event-based processing, right? Now, what can we do with this? We have something now very simple. I would like to see if you write this in your favorite language, how long it takes you to write the equivalent functionality. Maybe some people can do it in 5 seconds. 1 minute. Can everyone do it in 1 minute in your favorite language? All right. About 10% can do it. Can the rest do it within an hour? Okay, great. So, what can we now do with this which makes it more interesting? Because this is toys, right? What makes it streamed? Well, we can do things like can get the time. Oh, that's cool. It's just the time. From the time we can get the second. Second is second. We can take the time and we can ask for the change of a second. So each second is going to give us the value. We could also ask to get the actual second value. So we can do that. Now, we can also remove these. So what can we do with this? Well, we maybe can, let's do that again. So we take the second, extract the second value, we ask for a change every second, and we pipe it to S. This is the output of piping it to S. That goes on. We can now read it from S and hopefully take the odd seconds. Right? So each line in Panda is a process. That's how cheap they are. And you can pipe them together. You can put them together with these pipes, which wires it up. This is nothing new per se, but it's a great way to structure something. So what if we created a element in HTML called S, and we take, we ask for the DOM element of S. We say that the HTML of this should be S. What happens then? Doesn't happen. Oh, yes. Sorry. To make it HTML, I think. All right. Now we're working really well. So there's ways to connect things, right? So you can actually send messages to DOM elements and other things. Combining these things is interesting, right? Because if you see everything as being a function which returns a value, my editor is a function, and they give an initial value of the thing you're editing, and each time you save it, it emits a new value. And when you emit a new value, if it comes from a file, then you ask it to save it back to that file. So this is a simple way of making an editor and the file saving independent of each other. It's a stream of edits, conceptually, right? We can connect these things in different ways. For example, we can take the values 1 to 10, and we can send them to strange loop. And if any of you dare, you could actually go and get these values from strange loop, and they will be should be updated. Yes. So of course, this is not a long stream, right? So you have to run it again. But each time I run this, the values are sent to the global URL strangeloop.com. So it's just a URL made into a port. I have a backend service providing communication. So using this facility, you can very easily communicate between processes, between browsers. In my case, I choose to build Panda in the browser because you don't need to install it. So it's always available to me on my mobile phone, even. It's available to people on most devices. If you have Chrome, by accident, somebody tried to use it on the iPhone some years ago, and it worked, which was a surprise to me because I never tested that. It works on Firefox because it's very compatible, and that's pretty cool. So how do you combine these things? What can you do with it? Well, one example I was playing with was we load a module called cards, and just defines a small set of functions. For example, a deck of cards, you have a suite, and this have a display function which displays the representation of it, but it's really just these names. And as you see, this function actually returns 4 values in a stream, and so you can use them. We have a function where we can create a card of hearts with just give it hearts, and actually this is a value. All right, so, where this value underlying it is the actual object, but the display function chooses to display it with, right? So you can play with this. Now let's say that you actually wanted to have a deck of cards. You can then ask for 1 to 13. You get the cards of that color. What if you wanted to get all the cards? Well, we need to combine it with the suits. So we just enumerate all the suits, and then we get all the cards of the different colors, right? Of course, there is a way to get a whole deck of cards. Each time it happens to be the same, so that's kind of boring, but let's just shuffle this array of elements, and each time we get a different one, right? So this is a nice way to display your data and choose how to display it, right? So going back from here, you can easily interact with other elements. So for example, my website is jesko.org. My language recognizes that this is a URL. I don't know if there's any other language which have URLs as a data type built in, or where you can type a URL and it's recognized as a URL. But actually, we are in the age of URLs today, right? Or websites where this is a data object. And when we type it to a program, it doesn't understand what it is. Maybe you need to put quotes around it. You need to import the URL lib. And you need to call the new URL where you enclose it. And then you have a URL. What can you do then? Can the computer tell you what you can do with URL? Can it tell you how to load a web page? Usually not. You have to know which library to use, and there's a lot of choice of libraries, right? So this is where it gets interesting. Now in Panda, you can ask for the HTML, and we can choose to put it in an iframe, and so it does that. So it fetches the HTML and gives it an iframe. Usually, the function names in Panda are given as to what they return, what you want to extract or what you want to get, right? So if we have this HTML, we can now walk into the HTML by a get method, and we can ask to get all the h1 tags, all the h2 tags, all the bold words, things like this. We can then easily ask to get these words in a list item. So with a shorthand syntax where you just use a tag as a function, and it gets applied to the element, which then gets converted to HTML and displayed. This all is rather simple, but write the same program. This also takes only 1 or 2 sentences to explain, but how long it takes you to actually go and write it. Oh, can you go to this web page, this URL, and can you get all the bold elements from it and show them? That would actually take maybe 2 minutes. whereas maybe the first example is a little bit faster. So to describe it, we can say describe, and it generates a description of what it does. Of course, this works well for toy examples, but maybe we have other examples which are more complicated. That may be possible too. But this is automatically generated from the help system. And the help system is built on that when you define a function, you also define the documentation for that function. You also define test cases. And so if we want to look at a function, let's say sorry, I'm not used to this keyboard. The square functions in the system, these are the square functions we have. Let's say that we looking at the square function of a number. Now we have it here, and it knows that it's a safe function, it's a pure function. And this information, we tag the functions you implement in the background in the JavaScript or whatever environment you have, you tag them as to what they are. And because it's a safe and a pure function, we know we can call it 1,000,000 times. You also know we can cache it. We can cache a result of it. So this gives you the ability to reason about the functions used in the system. And we can also just expand the implementation, and it's just a simple math square root function right in the background. And this is possible to do for all the functions. So let's see. Here we have a function, same function more or less with different type signature, where we have examples. These examples are actually not examples, really. They're actually test cases. But the test cases serves as an example to how to use a function. And so they run it, and you see it says space diff here. And it says space diff, but you can actually run this code by just clicking on it, and you can see the result of it. And yes, it's 16, so I'm very happy, right? So I like the idea of documenting things when you go along. When you add a function, you add at least a minimal documentation to it. I noticed how the Tulip were saying that we need to write documentation, and that is interesting, and it's a big job. And maybe one person sits down and writes the documentation for the whole system. But if something changes, will that documentation get updated? Maybe, maybe not, right? So I think it's a great idea to combine documentation and code to keep it in one place. So you update one thing, you update the other thing, right? Now, if we look at all the functions in the system, there's quite a lot of functions. Interesting enough, a lot of functions deal with functions. So that's both good and bad. But we can, for example, ask which functions are pure. We can ask which functions are safe and things like this, right? So it means that we can make a sandbox mode where a user defines a function, and we can say like, oh no, this is not safe function. We won't allow you to run it because this is a user input function. So we can actually check the safety of something. So you can limit the amount of data you have. You're welcome to ask questions if there's any during the talk, because the slides are not here. That's a very interesting scenario. So feel free to ask. Yeah, sure.
So you have that syntax with the greater than sign, named types, or whatever you want to call them?
Yeah.
Can they be parameterized?
Yes. So what it actually is a function called, it takes a string, you give it, you call the function port, creates a port, and then you can send to that port, or you can listen to the port, or you can, of course, create a port from a URL. So those are two distinct ports. And you can also have a port. You can create a DOM element is also considered a port. So you can send messages to a DOM element, right? So, oh, sorry, the question was, can you create any port, or do you have to use the syntax, the literal syntax, right?
What I'm wondering is, can you have like an array of ports so that like you have 10 ports to find all at once?
Yes and no, because I have no variables in my language. So here's the thing. State, I try to avoid having state. State is not necessary for processing, because processing takes data changes and produces other changes, and these go somewhere. And so you don't always need a state. There's other ways to handle state, right? Like you could have a pipe which aggregates things, for example, right? So that's would be a counter state, but you don't have a variable which you updates the put and get directly, because this is often not needed in interactive system. So, for example, to create the, we can just create, that we can't do because it's not a, actually, if you say 80 port, that creates a port in Node.js which you can listen to and actually gets web requests. So a web server is a one line in Node.js. And it gets a web request. From that web request, you can extract things, and then you send data back. You send HTML back to that port. But if we just create a string here, and let's say we concat foo, then we can create these ports. So you can create a port when you need it. Usually, if you want to have a constant port you use in your program, which is opposite of what you ask for, you can create a function you call on to generate this object each time, and it's a possibility from a system to cache it because it would be a pure function which it can derive from all the functions involved, right? I understand your question because you're saying like, oh, we actually write big systems and we handle connections and we have state and we need to assign a port to a specific user maybe or something like this. And that kind of makes sense, but because you can construct these port names as a URL, for example, you have your own namespace of how you can actually build this thing. So you don't need to keep a pointer to it. It has a name, so you only have to invoke the name of it, and the name you can construct very cheaply when you need it. So that's one approach. Okay. Any more questions on that? Okay. So I'm sorry about the slides issue. Using old laptops is apparently not a good idea in the future, and we are in the future here. So, of course, you want to do different things than the simple things, right? So we can easily create a aggregation by just calling sum, and it uses special syntax. And you can imagine this curly braces squishing the expression in the middle, sending all the data to the sum function, which returns a single value or maybe no value at all. Okay. I'm going to see if something else works. So there's ways to improve interactivity, and naturally there's no reason why we shouldn't be able to just type and get the output for each keystroke. So this is trivial in these days in the browser, of course. Now it turns out that the programs you need to type this way and interact with the system don't need to be very long. So it takes essentially no time at all to do the analysis and compilation. By the way, so Panda gets parsed. So we can look at our silly example. It gets parsed to something called, I call it Pandalog. Datalog is datalog based, so this Panda expression will generate essentially a typed datalog. And as we know, datalog is a retractable prolog, which means it will terminate. it has a termination criteria because it enumerates existing data. Okay, and then from this we can very easily generate JavaScript. And you can create your own functions which generates its own JavaScript. That's how you can create special syntax or special type operators. One interesting thing with datalog, which most people may not be using, is that you can introspect it, and if you assign cost functions to cost values to your operators and fan out and selection. So, for example, an odd function have a selection of 50% because, in principle, half of the values of integers will fulfill the predicate, and the fan out is 1. It only gives 1 value. In this case, we can see that the iota function, it will actually generate 10 values, so the cost increases in the plan. And we also see that the square function will generate 10 values, and the less function estimates the output to 10%. In this case, it will giving maybe 3 values, right? If we change this to 100, we see how the cost says that there's going to be 100 elements in output. So this is a simple thing you can do. I was looking at other things, for example, how do you, sure. Okay, so for example, you are getting a web page from a URL. That's a big cost. It's maybe on the dignity of 10,000 compared to doing a square or something like this, right? So you can estimate the time it takes to run something, to run some code. And you can use this to decide to cache an operator or not on a language level, right? And also you can decide if it should be run interactively or not while you're typing, because if it actually takes too long, you can estimate it from a cost, you know this. So you won't run it very often until the user maybe presses return, right? And so these are things you can do. Just want to show another thing, like, for example, if you want to check if a number is a prime number, right? So we have p is 43, and assignment doesn't yield the value, so you have to say p. A prime number is essentially when the values, there's two numbers multiplied with each other, which yields the number in question, right? So we have to say times. So when these values multiplied together yields the value p, then we know it is a prime number. So if we give it 42, we don't get an answer at all. So Panda has the fail logic, right? So if there's no result, nothing is returned. Okay, I think we might have a 1 minute for question or more. I'm available afterwards. Okay, so we finished. I'm here. Please come up and talk. Thank you.